This video brings us to our last parent function of the class, and this is going to be a rational equation. So just like all of our other types of graphs, rational equations have their own kind of shape to them. First of all, in terms of what a rational equation actually is, I want you guys to think of the word fraction when you hear rational. A rational number is a number that you can express as a fraction with integers on top and bottom. So when we're talking about rational equations, the basic idea is that x is in the bottom of our fraction. And the most basic, our parent function for rational equations is y equals 1 over x. So this is a new type of graph because x is in the denominator of a fraction here. And that's something we haven't come across before. So we want to find out what this graph looks like. And like we always do when we come across a new graph, let's make a table and get some points. So I'm going to plot some points right here. And I'm going to start out by choosing the numbers 1, 2, and 3. If you plug in a 1 right here for x, 1 over 1 is just 1. If you plug in a 2, you get out a 0.5, or just 1 over 2. A 3 is 1 over 3, 4 is 1 over 4, etc. So if I start plotting those points right here, what I'm going to be looking at is a point right here. I had 2 comma 1 half, 3 comma 1 third, 4 comma 1 fourth. It's hard to be precise with such small grid right here, but essentially it's going to level off right there, and it's never going to hit 0 because whatever big number you plug in, if you plug in like 10 million, 1 over 10 million is still a really, really tiny decimal above 0. So we do have a horizontal asymptote here at 0. Let's say I decided to plug in a fraction for x, like a 1 half right here. 1 divided by 1 half is equal to 2. If I did 1 third, 1 divided by 1 third is equal to 3. 1 divided by 1 fourth is equal to 4, etc. So what's going to end up happening here as I go along, every time I take like my number and I'm plugging it in, my values for x are going to get really, really big. So this part of the graph jumps up like that. So we're looking at something similar to this as our fraction as we plug in positive numbers here. Now, this isn't our full graph. Right now it looks a little bit like an exponential because we can also look at what happens when you plug in negative numbers. Before I do that though, I'm going to try to plug in a 0. And you'll notice if you plug in 0 for x, 1 over 0 is not defined. You cannot do that. Plug in a 0 for x. That's why there's a vertical asymptote there at 0 because we're not allowed to divide by that number. So when we move on here and try some negative numbers, if you plug in a negative 1, 1 over negative 1 is negative 1. If you do negative 2, 1 over negative 2 is negative 1 half, etc. So what we end up having on this side right here is basically, okay, there's my 1, negative 1. Sorry, negative 1, negative 1. It's negative 2, comma negative 1 half, etc. It's going to be like a mirror image of my original graph, looking something like this. So what you actually have here for our rational graph, they typically have this kind of bow tie looking shape where there's two parts to it, one up here and one down there. Couple key features to wrap up this video. Let me move to a new slide for this one. Key features that I want you guys to be aware of. Rational graphs are different in that they have a horizontal and a vertical asymptote. That was new, something we hadn't seen before. So horizontal and vertical asymptotes at 0. And that's for the x and the y, assuming that it's untranslated, of course. And that's going to be kind of a big thing that you'll see in our next video.